My name is James Flum. I'm the Deputy Project Director, and this is the Improve I-70 Kansas City project. Today we're out here at the Benton Curve working on building fills in the median of I-70. Traffic right now is currently running on the existing westbound I-70 lanes, and we're in the median building the fills up for where the future alignment will be in 2027. This process of building embankments is not just as easy as coming in here, dumping the dirt down, building the highway and moving on. We go through the whole corridor taking borings underground to look at the different soil types that are out here. Some soils, when we put embankment on top of them, won't move. They're stable enough and firm enough that no settlement will occur. Other types of soils, when you put a large amount of embankment on there, will actually settle and compress. Part of the reason that we have to do these soil investigations is because what's out here right now may not have been in place hundreds or thousands of years ago. So if you think about this area here in downtown Kansas City and where the Missouri River is at currently, if you were to go back in time, the riverbed was originally in this location here. And so we're finding this layer around Truman Road in Benton that has riverbed type of soil. So knowing the history of the Missouri River and where it's at, and then corroborating that with our borings, we're able to make more informed engineering decisions on how to treat this soil. If we were to just put the embankments on the existing ground, 10 years from now, we would actually get large amounts of settlement. And so we're using wick drains out here to accelerate that settlement so that we can get as much of the settlement out before we pave the new highway on it. When you put a large amount of dirt on top of those poor soils, it actually squeezes the water out, and that's where the settlement comes from. The wick drains are a way for us to get that water out from the poor soils ahead of time so that when we put the dirt on, it can settle faster. So the material I'm holding right now is the wick drain. And essentially all that it is a corrugated piece of plastic with a fabric on both sides that wraps around it. So the wick drain acts kind of like a paper towel. When you use a paper towel on the counter and it comes up against water and the water goes all the way through the paper towel and absorbs it, that's what the wick drain does. So we're able to actually push the wick drain material deep into the compressible soils, and it acts like a paper towel, wicking that water from the lower level up to the drier, higher levels. For the installation of the wick drain, it starts as these rolls here. These rolls are taken and put onto the machine behind me. That machine has a really long arm in which we attach the rolls to, and a metal rod will actually force the roll all the way down 30, 40 feet into the ground in order to install that individual wick drain. On top of the existing ground and the wick drain, we put a foot of sand. The sand is porous enough that whenever the water comes from the compressible layers up, it's able to travel through the sand and escape out. So rather than just pulling the water from the ground to the top and then letting it come back down, the sand will act as a layer to help us get rid of that water from the area. We're then able to come in and start building our embankments on top of that sand layer. With the weight of the embankment pushing down and the wick drains having pulled the water out of the compressible soils, we're able to accelerate that settlement over a shorter amount of time. Here on the east side of Benton, we have an area in which we have installed the wick drains and placed our sand layer. You can see that in this area, it doesn't take just one wick drain to drain this entire area. It takes thousands of wick drains. Each one is carefully laid out with a flag ahead of time so that the machine can come up to it and install it in the precise location. Each of these wick drains are spaced about 6 feet apart as laid out in our plans. By using the wick drains to accelerate settlement, we're able to shorten the length of our projects. The alternative here is that we would have to build our embankments up and let the ground naturally settle over 2 to 3 years. This process allows us to use the technology of the day to accelerate the settlement, create shorter projects, and allow the drivers to experience the benefits of the project much quicker.